Hello everyone, here is today's problem. We are asked to find the maximum of square root 2xy plus yz if all xyz are positive and the sum of the square equals 1. We are going to give 3 different methods to get the value. Please have a good try before you look at the answer. Before you get the method, let me tell you the quick answer. The answer should be square root 2 squared plus 1 squared, the whole thing squared over 2. That's square root 3 over 2. And I'll let you know how do I get the answer. So for method 1, we're going to use just AIME inequality. Note that x squared plus 2 over 3y squared is greater than equals to 2 of square root 2 over 3 x squared y squared. And this will equals 2 over square root 3 square root of xy. Next, 1 over 3 y squared plus z squared will be greater than equals to 2 of square root 1 over 3 y squared z squared. And this is 2 over square root 3 yz. And we take the sum of these two inequality, we get the left hand side x squared. For y squared, it is 2 over 3 and 1 over 3, so it is y squared. And for z squared, it is z squared. This is greater than equals to 2 over 3 square root of 2 xy plus yz. And on the left hand side, it is equal to 1. This means that square root of 2xy plus yz will be less than equals to square root 3 over 2. Is the value square root 3 over 2 the maximum? We need to check whether the equality holds. Equality holds if and only if x squared equals to 2 over 3y squared and 1 over 3y squared equals to z squared. So after we solve all this, we will see that x, y, z can be only this value, that is 1 over square root 3, 1 over square root 2, and 1 over square root 6. This means that this maximum value is indeed equal square root 3 over 2. For method 2, we will combine AIME and Cauchy. Note that 2 plus 1 x squared plus z squared is greater than equals to square root 2x plus z whole thing squared. Likewise, 3y squared is greater than equals to square root 3y the whole thing squared. So when we add up these two together, we get 3 of x squared, y squared, and z squared, which is greater than equals to square root of 2x plus z squared plus square root 3y squared. And now, using AIME inequality, this is greater than equals to a double of square root 2x plus z and square root 3y. And this is equals to square root of 2xy plus yz multiplied with 2 square root 3. Okay, we are almost done. But looking at the left hand side of the inequality, x squared plus y squared plus x squared equals 1. So this is equals to 3. So this means that square root of 2xy plus yz will be less than equals to 3 over 2 square root 3, which is square root 3 over 2. In this case, we use AIME inequality and Cauchy inequality. So we need to make sure that the equality holds for all the conditions. So equality holds if and only if this x over square root 2 equals to z over 1. And for this case, square root of 2x plus z equals square root 3y. And after we solve the equation, the answer is again x, y, z equals to 1 over square root 3, 1 over square root 2, and 1 over square root 6. And again, we can conclude that the maximum is indeed equals to square root 3 over 2. So this end of method 2. Now we go to method 3, which is we are using trigonometric substitution and our formula. Since x squared plus y squared plus z squared equals 1, we let x to be sine theta sine phi, and y equals to cosine theta. Z equals to sine theta cosine phi. So using this substitution, you may check that x squared plus y squared plus z squared equals 1. So square root of 2xy plus yz equals square root of 2xy plus y and z. Then we can see that there's a common term, sine theta and cosine theta. The rest, it is square 2 sine phi plus cosine phi. And for sine cosine, it is equals to half of sine 2 theta. And for this, we know that this is equals to square 3 multiplied with square 2 over square 3 sine phi plus 1 over square 3 cosine phi. So this will be equals to square 3 over 2 sine 2 theta, and this will be sine theta plus alpha, where tangent alpha equals 1 over 2. And therefore, this is less than or equals to square 3 over 2. Equality holds if and only if theta equals to 45 degree and phi plus alpha equals to 90 degree, which is achievable. And therefore, we have the same conclusion. The maximum is indeed equals to square 3 over 2. So these are the three methods to show the maximum of the expression is square 3 over 2. That's all for today's lesson. Hope you enjoyed it. I'll see you again next time. Bye bye.